Good morning, good afternoon, or good evening, whatever time you're watching this educational video about instantaneous acceleration. And we all know in order for us to get the instantaneous acceleration, we have to get the derivative of our velocity function, or v with respect to time, or velocity with respect to time, or v of t. But in this case, in our problem, using a function x of t is equal to t cubed minus 9t squared plus 5t as the location of the mechanical object. And this object is moving and the function of position is given. And if that's so, we need to get the derivative of the uh, position function in order for us to have the velocity function, because the derivative of your position function is our velocity function, or our v of t. And then if you will get the derivative of your velocity function, that's the acceleration function. And that's the time that you will substitute the time, and you will get the instantaneous acceleration. In this problem, we have you need to provide the velocity at 0 second and its acceleration or instant acceleration at 1 and 2 seconds. But in this problem, we will be focusing on providing the velocity at 0 second, and we have to provide the velocity when the acceleration is zero. I forgot that there is this problem that we need to solve the instantaneous acceleration at 1 and 2 seconds. Okay, but we will focus on providing velocity at 0 second and provide the velocity when the acceleration is zero. Okay, now, first thing that we will do is get the derivative of the position function, or the x of t, and that's our position function here. And if we will get the derivative of this position function, we have this will be the power rule will be applied. So 3 times we have 1 here, and then that will become 3. 3 times 1 is 3, and then 3 exponent 3 minus 1, that is 2. So you have 3t squared minus 2 times 9, you have 18. 2 times 9, you have 18, and then t squared 2 exponent 2 minus 1, and that is now t. And then you have 1 here. So 1 times 5 is 5, and then 1 minus 1 is 0. That's why it becomes constant here, 5. So this is now the derivative, the first derivative from our function, position function. And this will be now our velocity function. And in this case, we can be able to have or to provide the velocity at 0 second, because we already have the velocity function. Okay, and we have a specific instant time, that's 0. And what will be our velocity if the time is 0, or at 0 second? Substitute directly the time 0 or 0 second to our velocity function. So this is our derived function. So we have our velocity function here, and we will just substitute 0 to our time variables in this function. So you can see 0, and we have 0. And as we all know, anything being multiplied to 0, the answer is 0, so we can cancel out these terms, and we will have the remaining term 5 meter per second. That's the unit of our velocity. So at 0 second, the velocity is 5 meter per second. Okay. Now, problem B, velocity at 0 second. So problem B, provide the velocity when acceleration is 0. Okay. So this is our velocity function. We derived it from our position function here from the given. And since we're talking about acceleration here, we need to get the derivative of our vt function in order for us to equate it to acceleration function. Okay, so we will derive vt from, yeah, this is the derivative of vt from xft. And now let's get the derivative of the velocity function. That's vt in order for us to get the instantaneous acceleration. Okay, now we have vt. This is the velocity function. We will get the derivative of it. So we have 2 times 3. Okay, 2 times 3, you will have 60. And then this is 1 here. 1 times 18, it's negative 18. So this is now the derivative of uh, velocity function, and this is being differentiated into acceleration function, or a of t. And at 0 second, not 0 second, let's go back to the question, provide the velocity when acceleration is 0. So we will just equate our acceleration into 0. Okay, and from this, we will equate it to 0. And we can get the time, the variable of time, out from this equation. So we will transpose negative 18 into it, and it will become uh, positive 18. And then 60, we will divide both sides by 6. And then we will get 3 seconds as the time. And at 3 seconds, acceleration is 0. We will go back to our velocity function. We will substitute the time, 3 seconds, to our velocity function. Here is our velocity function here. Yeah, we will use this again and substitute directly the time, 3 seconds, in the time variable. So at 3 seconds, so you can see we substituted here the 3 seconds that we we calculated from the acceleration function. Okay, and given that our acceleration is 0, so the velocity when acceleration is 0 is negative 22 meter per second. Negative sign there is just the direction. So there's a change in velocity. uh, I mean, there is a change in direction. Okay, in this case. Thank you so much for watching, and I hope you enjoy and learned something from this video. And of course, you can like this one and even subscribe to this channel. See you on the next video. Bye for now.